Hi children, welcome to another class. In this session, we are going to discuss the JEE mains paper conducted on June 2022, June session 2022, and the paper is 24th June. 24th June evening session. (2022) G mains. So G mains 2022 24th June evening session paper we are going to discuss in this session and the chemistry part of it. Can we start? Ready? Yes. We have the first question from section A. 120 gram organic compound that contains only carbon and hydrogen give 330 gram carbon dioxide and 270 gram of water on complete combustion. The percentage of carbon and hydrogen is the question. I am sure you know Liebig's combustion method for finding the percentage of carbon and hydrogen. So what is the formula? Finding percentage of carbon is equal to, see, carbon is estimated as carbon dioxide. So it is 12, the weight of carbon, divided by 44, the molar mass of carbon dioxide, into weight of carbon dioxide obtained in the experiment, divided by weight of organic compound into 100. You know the formula. This is the formula for finding the percentage of carbon, right? Because carbon estimated as carbon dioxide. So carbon dioxide contains carbon 12, the molar mass 44, weight of carbon dioxide obtained in the experiment divided by weight of organic compound into 100. How much you get? It is 12 into, what is the weight of carbon dioxide? 330 into 100 divided by 44, the molar mass of carbon dioxide, into weight of organic compound, 120. How much you get? You see that? You see that? Easily you can cancel 12 with the 0, 120 out. And you know this 33 by 44, it is 3 by 4. 3 by 4 into 100, you get 75%. 33 by 44, it is 3 by 4. 3 by 4 means 75%. So carbon is 75%, and we don't have to find out the percentage of hydrogen. Why? If carbon is 75%, quite naturally it contains only carbon and hydrogen, the percentage of hydrogen will be 25%. So it is 75 and 25. Answer is option D. 75 and 25. Answer is option D. Okay, that's it. Answer is option D. Right? Next question. The energy of 1 mole photons of radiation, wavelength 300 nanometer. Energy of 1 mole photon of radiation, wavelength 300 nanometer. So how do you find energy? Energy E is equal to NH nu. For 1 mole, it is Avogadro number into H nu. Wavelength is given, so it is Avogadro number into Hc by lambda. You know Avogadro number, you know H value, you know C value, and lambda value given. How much? 300 nanometer. So it is 300 nanometer, that is 300 into 10 power minus 9 meters. Upon substituting, you can find out the answer, right? So what will be the calculation? What will be the calculation? You see, H C Avogadro number by lambda will take you to somewhat 400 range, 400 range kilojoules, 400, 399.13 into 10 power 3 joule per mole. Simple calculation only. The substitution is simple data, so you can easily calculate. You will get close to 400, and only one choice is in the range of 400. You can easily figure out. Answer is option C. As it is coming 399 close to 400 into 10 power 3 joule per mole, and it will be 399 kilojoule per mole. Clear? We are talking about 1 mole photons. So E is equal to NH nu. For 1 mole, N will be Avogadro constant. Right? Next. Third question. The correct order of bond orders C2 2 minus, N2 2 minus, O2 2 minus. You know the configuration for O2 and N2. There is a slight difference. Where is the difference coming? For oxygen, we will be taking sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px, pi 2py, like that. Whereas for nitrogen, there is a difference between sigma 2pz and pi 2px, pi 2py. There will be a change. And for nitrogen as well as carbon, you can write almost the same configuration. For oxygen, you will be writing a different configuration to find the bond order, and the values will be, what are the values? You know the values. Oxygen O2, O2 bond order is 2, you know, right? And now O2 minus bond order will be 1.5 as the new electron entered into anti-bonding molecular orbital. And O2 2 minus bond order will be 1, as you see here, right? In a same way, nitrogen, you know, bond order is 3, right? And the configuration nitrogen end up in sigma 2pz, right? Therefore, nitrogen, when you add more electron, the bond order 3 will reduce it to 2.5 as the new electron enter into anti-bonding molecular orbital. And 2.5 becomes 2 when one more electron is added. You know the configuration. Similarly, you can figure out how is coming in C2 and C2 minus, C2 2 minus, and the order is 3 2 1, giving the answer option B. This is minimum, then nitrogen, then C2 2 minus. That is the answer, option B. Okay, on to the next question. Next question. Fourth one. You see, enthalpies of combustion for hydrogen, carbon, ethane given. Enthalpies of combustion for hydrogen, carbon, ethane given. Ask you, what is enthalpy of formation of ethane? Right? How to find out enthalpy of formation of ethane? You see, ethane formation C2H6. It should require 2 carbon and 3 H2. So 2 carbon plus 3 H2 will give you formation of ethane, and we want to know what is the enthalpy for this. And it's quite simple. All of you know it is the sum of delta H for such a reaction. Sum of enthalpy combustion of reactants minus sum of enthalpy combustion of products. So what is enthalpy combustion of reactants? That of carbon. How much? Carbon minus 394 minus 394 into 2. Minus 394 into 2. 2 mole carbon. Okay. Plus hydrogen. Hydrogen minus 286. Minus 286 into 3. Into 3, as there are 3 hydrogen. minus that of ethane minus 1560. Is that clear? Upon simple calculation, you've been able to identify the answer. First of all, you have to look at this is the minus figure. This is minus of minus will become plus. So which is the greater data? This is going to be the greater data or that one? Because that's going to be plus and this is going to be minus. Right? I think simply investigating, you will find out, you can easily find out the answer will be plus or minus and then the figure also. See, there are two plus data and two minus data. First of all, you can figure out plus or minus and then the final figure also. And the answer will be option C. Option C. That means you are getting minus 86. Minus 86. Okay. That means it's quite evident that this data will be slightly greater than this data. Okay. Next. Fifth question. For a first order reaction, time required for completion of 90% reaction is X times half-life of the reaction. Value of X is. So time for 90% completion. Time for 90% completion. It is 2.303 by K log 100 by 10. That will be 2.303 by K, 2.303 by K log 10. Log 10 is 1, isn't it? And now, what about T half? T half is equal to 2.303 by K log 100 by 50, you know. It is log 2. So, what do you get? 2.303 by K into log 2. Log 2 will be 0.3. Now, see what is the difference? What is the difference? This 0.3 and 1. You know, 0.3 into, how much you get 1? 0.3 into 3.3 times, isn't it? Isn't it? Some 3.3. Option C will be the correct answer. Because 3.3 into 0.3, that will be 1. Isn't it? So compare this and this. Because the other part is same, no? So this almost 3.3 times you will get this. Hope you understand. Clear? Option C. Option C is the correct answer. Next one. Metals generally melt at very high temperature. Among the following, metal with the highest melting point. Highest melting point. No doubt. Option B. Because this is liquid state. This is in the liquid state. And these two are in the liquid state in a reasonably hot condition. In a reasonably hot day, cesium and gallium can be in the, they have not a low melting point, but still they are in the solid state. Okay. So this is in the solid state normally, but they can be in the liquid state in a reasonably hot condition. Meanwhile, silver is having a reasonably good melting temperature, reasonably high melting temperature when compared. Okay, next. Hall-Héroult process. Hall-Héroult process. Extraction of aluminium. Hall-Héroult process is extraction of aluminium. Electrolytic extraction of aluminium using alumina. Right? Next. Molecular hydrogen obtained as a byproduct. Molecular hydrogen obtained as a byproduct in the industrial production of NaOH in Kastner-Kellner cell. In Kastner-Kellner cell, refer NCERT, preparation of industrial preparation of NaOH, we are getting hydrogen liberated. And I am sure you know the reaction so happening like this explained in detail in the textbook. You see the reactions explained in detail in the textbook. You see that at the cathode, You can see sodium interact with mercury giving sodium amalgam, and at anode chlorine gas will be liberated. Now this sodium amalgam when treated with water, there will be a controlled reaction. Otherwise sodium giving a violent reaction. Amalgamated sodium giving a controlled reaction, and you are getting NaOH liberating hydrogen gas. And that was the question. Okay, next. Option A. Used in fire extinguishers, sodium hydrogen carbonate, sodium hydrogen carbonate, which otherwise called a baking soda. Next. PCl5 is well known, but NCl5 not, because nitrogen less reactive than phosphorus. It is a true statement, but not connected to this. Nitrogen doesn't have d orbital. That is the correct answer. Due to the absence of d orbital, nitrogen cannot extend its covalency beyond 4, and that is the reason why NCl5 does not exist. A well-known discussed point in the classes. Next. Transition metal complex with the highest value of crystal field splitting. See, all are water. All ligands are water. Usually we decide this answer based on the ligand. For such a question, we decide the answer based on the ligand. Here all ligands are water molecule. So aqua complex, which is more stable? Is it chromium, molybdenum, iron, osmium? Please understand, 5D metal ions will be giving you stable complexes when compared. So aqua complexes of osmium will be the answer, as it is a 5D series, third transition series. You know, third transition series is having unexpected lower size because of lanthanoid contraction. Okay, next. Some gases are responsible for heating of greenhouse effect, which is not a greenhouse gas. That is the point. Nitrogen. Nitrogen is not a greenhouse gas, while others are. Next. Arrange the following carbocations in decreasing order of stability. Decreasing order of stability. For this particular question, we can see that the official answer key reported by NTA is B. This is the official answer key reported. A greater than, B greater than C. This is maximum, then this, then this. But that is not that much justifiable answer. A justifiable answer, we can say, it is like this: B maximum, then A, then C. And such a choice is not available also. B maximum, then A, then C. Why B is maximum? B is maximum because this carbocation can be stabilized by the resonance effect of lone pair of electrons with oxygen. Did you understand? Moreover, here you have two alpha hydrogen atom which can stabilize this system by hyperconjugation. So B should be maximum. Now, what about the next one? A. Here this carbocation may be stabilized by the hyperconjugative effect of these four alpha hydrogen atom. Therefore, A next. Now, C minimum, because this may be stabilized by the alpha hydrogen atom here as well as here. At the same time, this oxygen is present even though it is in the third position. It can provide minus inductive effect. So due to the minus inductive effect, we can expect the stability of the carbocation slightly less when compared. So this is a possible acceptable order, while the reported answer seems to be option B, and that is not that much justifiable. Okay, next. two statements. The presence of weaker pi bond makes alkenes less stable than alkanes. The strength of double bond is greater than for carbon-carbon single bond. So presence of weaker pi bond make alkenes less stable means more reactive. It's a true statement because of loosely held pi electrons. It is easily attacked by electrophiles. A well-written statement and the fact and figures we know regarding the reactivity of alkenes, right? Now coming to the second one, strength of double bond is greater. That is also true statement. Which one? Option A. Both the statement 1 and 2 are correct. That is the correct answer. Next question. Option A. Which of the following reagents reaction will convert A to B? We want this to get converted to this. Is it PCC oxidation, ozonolysis? Is it hydroboration followed by PCC oxidation? And that will be the correct possibility. Option C will be the correct possibility because during hydroboration, we can introduce a OH group over here. You know the speciality of hydroboration. It involves a hydration process in such a way that OH group comes in the terminal carbon if possible, right? So there is an OH group will come here, you get CS2OH, and with the PCC it will be converted to CHO group. You see the reactions, children. You see the reactions. Simple reaction you can understand based on the fundamental knowledge you know regarding hydroboration reaction. Hydroboration oxidation. It is written here, this is a wrong comment. It is not so called anti-Marconic of addition. It is not anti-Marconic of addition. We can say that the product obtained is similar to anti-Marconic of product. It is not anti-Marconic of addition or it is something like that. It is a concerted mechanism. It is a covalent reaction where boron is added to the terminal carbon and hydrogen added to the interior carbon, and so that finally such a group will give you CH2OH, and with the PCC this will be converted to CHO. And the answer is option C. Next. Hex 4-ene-2-ol treatment with the PCC gives A reaction with the sodium hypoiodide gives B, which on further heating with the soda lime gives C. We want to get what is C, right? Let's investigate hex 4-ene-2-ol. Hex 2-ol 1, 2, 3, 1, 2, 3, 4. This is hex 1, 2, 3, 4. 4-ene-2-ol. This treated with the PCC. You know this when treated with the PCC you will get this OH will turn keto group 1, 2, 3, 4. There is double bond retained. You get this one. So OH group will be oxidized to CO group. Now this is treated with the sodium hypoiodide. This treated with the sodium hypoiodide. I think all of you know what is the reaction? Iodoform reaction. And what is the result of iodoform reaction? Is going to cleave over here. This carbon will be converted to CHI3 and the remaining will become C1, 2, 3, 4, 5, 6 COOH 1, 2, 3. Third carbon there is double bond. This is what the product. Right? Now this treated with the soda lime. This treated with the soda lime, NaOH and calcium oxide, there will be what reaction? Decarboxylation. It will undergo decarboxylation and this group will be eliminated and you get 4 carbon alkene, 1, 2, 3, 4 carbon alkene, and that is the product, means 2-butene. 2-butene. Option C is the correct answer. 2-butene. Is it clear? I'll repeat. This is the given compound A. A with the PCC you will get B, and no, this is the compound which when treated with the PCC you get A. This is A. This undergoing iodoform reaction you get this and this. This is B, and this with the soda lime you get C, and this is the product C which we are talking about, butene. I have simply written the skeleton. Hope you understood what I meant. Okay, next. C. The conversion of propan 1-ol to N-butylamine involves sequential addition of the reagent. The correct sequential order of the reagent is, let us verify the first one. Let us verify the first one. Propan 1-ol. This is propan 1-ol. I'm just writing the skeleton. Hope it's okay. It is treated with the SOCl2. This is treated with the SOCl2. You get propan 1-chloride. 1-chloropropane. Now this is treated with the KCl. This chlorine COH group will be replaced by chlorine when treated with SOCl2. With the KCN, what do you get? You get CN. Chlorine replaced by CN. Now this is reduction. This is reduction. The so-called Mendeus reduction. And the Mendeus reduction, the result will be NH2. This C will become CH2. This N will become NH2. Now what is the result? CH3, CH2, 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 NH2. What is that? N-butylamine. Oh my God, that itself is the answer. So propan 1-ol treated for such a sequence, finally you end up with, you land in N-butylamine, and the answer is option A itself. Now you please verify what will be the result if you take option B, option C, option D. Whether there will be a reaction or not, you can investigate. I think all the reactions that we learn only. Okay, next. So first choice itself is the answer. Not an example for condensation polymer. This is condensation polymer, this is condensation polymer, and this is not a condensation polymer. Buna-N. Buna-N is obtained by 1,3-butadiene. 1,3-butadiene plus acrylonitrile. Plus acrylonitrile. This and this will give you CH2, CHCN, acrylonitrile. With 1,3-butadiene, you get Buna-N. It is an addition polymer. It's an addition polymer, while all others are, this also is condensation polymer. Option C. Well-known drug molecule. See, the structure is available in the textbook. Cimetidine. The structure is available in the textbook. And the answer is cimetidine. Please verify with the NCERT. Okay, next. A green flame with the blue center. A green blue center. Copper. Copper is going to give you a green blue flame. What about the others? Strontium, barium, calcium. What are the possibilities? Strontium, it is giving some crimson color. Barium, apple green. Calcium, that's also somewhat brick red, right? Crimson red. All are there in the text. Copper will give you some greenish blue greenish flame. Next. Now on to section B. That's about section A questions. Now on to section B questions. Okay, section B. At 300 Kelvin, 3 gram gas A occupies same volume as 0.2 gram hydrogen at 200 Kelvin at the same pressure. Molar mass of gas A is dash times dash gram. Assume that the behavior is an ideal gas. So 3 gram gas A occupies 3 gram gas A occupies at 300 Kelvin same volume as 0.2 gram hydrogen at 200 Kelvin at the same pressure. So assuming ideal behavior, PV is equal to nRT, pressure is constant, volume is same, this is constant, so these two are the variables. Those two are the variables, so it is N1 T1 is equal to N2 T2, that is W1 by M1 T1 equal to W2 by M2 T2. So what is W1? 3 gram of gas, 3 divided by molar mass into 300 equal to, what is W2? 0.2 gram hydrogen 2 into 200. You can easily find out what is the answer. You can easily find out what is the answer. So what happens? 2, 200, 100, 3. So it is 9 by 0.2. M is equal to 3 into 3. 9 by 0.2 means 90 by 2. The answer will be 45. Answer will be 45. Oh no, it's 45. 45 is the answer. Next question. A company dissolves X amount of carbon dioxide, X amount of carbon dioxide in 1 liter to prepare soda water. So what is X? So partial pressure given, partial pressure of the given partial pressure of carbon dioxide at 298 Kelvin, K given, Henry's law constant. Henry's law constant given. So Henry's law constant given, partial pressure is given. Partial pressure is given, Henry's law constant is given. You can find out the solubility. You can find out the solubility. How? P is equal to KH into X. This is given, this is given. You can find out this. That is the solubility, mole fraction. From mole fraction, you can find out what is the mass of carbon dioxide dissolved. You have to work out and find out. You see that? So there can be two different, slightly different answers. So P is equal to KH into X, and thereby P is equal to KH into X. Suppose you are substituting Na by Na plus Nb, you will get the answer somewhat 1222.8, rounded off to 1 2, how much? 1223. 1223. Suppose you are approximating. P is equal to KH into Na by Na plus Nb. You take Na by Nb, assuming this to be a small figure, approximating. You will get a data 1222.2, which can be rounded off to 1222. So the answer can be 1222 or 1223. While the reported answer by NTA, it is 122 is okay, but they are reporting 1221. Slight difference in the answer reported. Anyway, there are two choices of answer: 122, 1222, and 1223. Or the reported 1221. That's a slight variation, because such confusions are inevitable in such a numerical question. We have to be pretty careful. Next. PCl5 dissociates as 5 moles PCl5 placed in 200 liter vessel, contain 2 mole N2, maintained at 600 Kelvin. Equilibrium pressure is given 2.46. We want to find Kp. We want to find Kp. Right? So let's see how it can be solved. How it can be solved. Let's say 2 mole N2 gas present as inert gas. N2 is not a part of this reaction. So 2 mole N2 present as inert gas, isn't it? Now what is the reaction? PCl5 initially taken is 5 and PCl3 will be 0 and Cl2 will be 0. Now at equilibrium PCl5 X react. So remaining will be 5 minus X. And PCl3 will be X and Cl2 will be X. Is that clear? Is that clear? Fine. Now, from the ideal gas equation, PV equal to nRT, pressure is given in the question 2.46, volume is given in the question 200, and you can find out N. R is available, T is available, RT available. You can find out N. What is N? Number of moles of PCl5 remaining 5 minus X. Number of moles of PCl3 X, number of moles of Cl2 X, and number of moles of nitrogen, don't forget, 2 mole. So the total number of moles in the container, 5 minus X of PCl5, X of PCl3, X of Cl2, and 2 for nitrogen. Is it clear? So this we can work out. All these data we know, we can find out X. You will get X as 3. You will get X as 3. Now it's over. You get X as 3 means you get Kp, number of moles of PCl3, Cl2 divided by PCl5, P total by N total. Or the traditional way, you know, Kp is equal to partial pressure of PCl3 into partial pressure of Cl2 divided by partial pressure of PCl5. That will be mole fraction of PCl3 into total pressure, mole fraction of Cl2 into total pressure, mole fraction of PCl5 into total pressure. One P will get cancelled. So substituting, you will arrive into the same data, right? Now, number of moles of PCl3, X, 3. Now the other one, 3. And 5 minus X, 5 minus 3, it will be 2. So 3 into 3 by total pressure 2.46 commented in the question, divided by total number of moles will be, this is 3, this is 3, and this is 2. So it will be total number of moles. What is total number of moles? 3 plus 3, 6 plus 2, 8 only. How come 10? PCl3, 3. Chlorine, 3. 3 plus 3, 6. PCl5, 2. So 6 plus 2, 8. How come 10? 2 nitrogen. 2 nitrogen. So the total number of moles in the numerator, in the denominator, that will take you to the answer. 1.107 to be reported as into 10 power minus 3 becomes 1107. Okay, 1107 will be the answer. Next one. The resistance of conductivity cell containing 0.01 molar KCl solution. So resistance R is given. Conductivity kappa is given. What is the cell constant? You know the relationship between kappa, resistance, cell constants. What is the relation? What is the relation? This is the relation between kappa, resistance, and cell constant. Kappa is equal to cell constant by resistance. The data direct substitution, kappa is equal to cell constant by resistance. You get the answer directly. 266, 10 power minus 3. You see, all the answers will be reporting in that way only because it is numerical part and the answer to be entered in the digital format. Answer is 266. 266. Direct substitution. Next one. 200 ml 0.2 molar acetic acid shaken with a 0.6 gram wood charcoal. Final concentration of acetic acid after adsorption is 0.1. Mass of acetic acid adsorbed per gram of carbon is. We want to find out X by M. We want to find out X by M. Okay. So what is the logic? What is the logic? You see, weight of wood charcoal is 0.6 gram. Mass of acetic acid adsorbed. Mass of acetic acid adsorbed. It will be M1V1 minus M2V2 divided by 1000. M1V1 minus M2V2 divided by 1000. That will be the number of moles of acetic acid adsorbed. So M1V1 quantity, number of moles initially, M2V2 finally. So we get the difference. We will get the number of moles of acetic acid adsorbed. So how much is taken? 0.2 molar 200 ml. What is finally available? 0.1 molar 200 ml. So that will give you the difference. Into molar mass of acetic acid. That will give you the mass of acetic acid adsorbed. So what is the mass of acetic acid absorbed? Easy calculation. You will get 1.2 gram. So 1.2 gram acetic acid adsorbed over 0.6 gram activated charcoal. So how much per gram? 1.2 divided by 0.6. It is 2. Answer is 2. Clear? Next. A, B, C, D. How many of these are sulfide? How many of these are sulfide? This is not sulfide. This is sulfide. This is sulfide. And this is sulfide. 3. 3. All are well-known examples. All are well-known examples. This is barite. Text. Refer the text. Galena, zinc blende, copper pyrites. These 3 are the sulfide ores. Barite means barium sulfate. Next. Manganese 6. Manganese 6. Manganese 6 means manganate. Manganate. Manganese 7 is permanganate. Manganese 6 has the ability to disproportionate in acid solution. The difference in oxidation state of two ions it forms in acid solution is well-known disproportionation reaction. Well-known disproportionation reaction MnO4 2 minus where manganese is plus 6 will be disproportionate to MnO4 minus where manganese is plus 7 and MnO2 where manganese is plus 4. So what is the question? The difference in oxidation state in the product side. Plus 7 plus 4. What is the difference? Plus 7 plus 4. What is the difference? It is 3. 3 plus 7 plus 4. The difference is 3. 3. Next. .2 gram organic compound subjected to Dumas method. Volume of N2 released is 20.4 ml. Percentage of nitrogen in the compound is, you know the formula? You know the formula? Percentage of nitrogen is equal to 28 divided by 22,400 into volume in milliliter into 100 divided by weight of organic compound. So how much you get? 28. How much? 22.4 into 100 by 22,400. What is the weight? 0.2. So 22.4 into 100 means 2240, right? 2240. So this will be 10. right? 10 with the 2. So 28 by 10 with the point 2, it is 2. 28 by 2, the answer is 14. Answer is 14, right? Answer is 14. See that? Next. Consider the reaction number of pi electrons present in the product P. Number of pi electrons present in the product P. See the compound subjected to hydrolysis. The compound subjected to hydrolysis, there is nothing special. Chlorine will be replaced by OH, isn't it? Chlorine will be replaced by OH, nothing else. So they are asking number of pi electrons, not pair. Number of pi electrons in the product. There are 2 pi electrons, 2. Because the pi electrons are subjected to no change. Chlorine goes, OH comes. That's it. Answer is 2. 2. Next. Alanyl, glycyl, leucyl, alanyl, valine. Oh. Alanyl, number of peptide linkage. Alanyl, glycyl, leucyl, alanyl, valine. How many peptide linkage? 1, 2, 3, 4. 4 peptide linkage. Between 2 amino acids, there will be a peptide linkage. How many amino acids? 5. 4 peptide linkage. So the answer is 4. Answer is 4. And that was the last question concerned in that paper. We were discussing, as I said earlier, we were discussing the latest 2022 JEE Mains examination, June session. 24th June evening paper we were discussing. We will meet in another discussion class with another chapter or another discussion paper. Okay. Till then, bye. See you.